Today, I want to talk to you about something that I have spent a lot of time thinking about in the last about a year, and it's about how we use code in empirical research. And if you're new here, welcome. I'm Gerger. I'm in the second year of my PhD applying network and data science methods to the management domain. So while the domain that my research mainly focuses on, which is broadly management, doesn't immediately bring computer science and coding to mind, code plays a much bigger role than one would imagine. Because, like statistics is one thing, but to get the data from the raw source, to get it cleaned, to get cleaned up, to even just like do your modeling, right? All of these are steps that involve code in some capacity. So if you are a little grasshopper data scientist, like I was, then you probably learned coding in Python using Jupyter notebooks, which is kind of like the end all be all, right? Or if you come a bit more from the social sciences side, maybe you used R Markdown and R. But essentially you relied on notebooks, and then basically your code base looked like a notebook, which has like, hopefully it has a name, it's not untitled 1 to 19, like in the case of some bachelor project I've seen. So you had a notebook with the title, and then you run it cell by cell, and then at the end, like you have whatever you want to see. And I think an approach like this can get you surprisingly far. I'm not the biggest fan of notebooks because I feel like we should separate, the code from the state, but that's a different discussion. But there came a point in your career, it certainly came one in mine, when I realized that this approach of just like having a notebook, running it top to bottom is just not gonna cut it. Either because you wanted to try some different stuff and then you ended up like replicating a bunch of code or just duplicating a notebook and then, just like changing it in one notebook and then forgetting to change it in the other, and the whole thing became a mess. And then you realize that something needs to change. Okay, from here on, I'm not gonna talk about you, I'm gonna talk about me. It was my experience. So, grain of salt. So I was sitting there with all of my notebooks being a big mess, and I felt that there has to be something there. And then I realized like, oh wait, actually there is two fields of science, one of them being computer science, the other being software engineering, which kind of complement each other in this, that are kind of all about like how to do this really well, right? A large part of software engineering is figuring out stuff like abstraction and all of these behaviors and characteristics of a good code base. So I went super hard on learning everything I can about good software engineering practices, like clean code practices, and all of it to make my life hopefully easier. The first thing that I think that I picked up out of all of this was a formatter. I used to be really, really against formatters, because I was like, it's my code, I will do with it whatever I want, why should I listen to some random little script tell me how my code should be formatted? And over time I realized that there is a reason why formatters are kind of like industry standard, right? And to me, the main reason that like why I use a formatter to this day is because the ability to just like, not even the ability, but a formatter enables every single project and piece of code I'm working on to look the same, which sounds, it might sound like a small thing, but it's massive. It's a game changer, right? Because I can just open up any file that I'm currently working on and that I worked on. I can just open it up, and if I see a function definition, I know how the flow is gonna look. And I don't have to wonder about 19 layers of abstraction and nesting and everything. And this is just not an issue anymore. A formatter just really enabled me to lower the cost of context switching and switching between projects, because all of my code just looks the same. So it's nice and easy to read. I can have it in half the screen because, it's shorter lines and everything. So it just encouraged me to write nicer code. And code readability is, a massive piece of making your code easy to debug, and that, you can revisit it and still understand it down the line. So formatters are definitely one that will stay with me, and I absolutely love them now. I will also link the formatters that I use in the description. I have one for Python, I have one for R, and I also have one for SQL, but that took so much work to set up that I will just not even touch on that. But I will link the R and Python versions in the description. The other big piece about that I started borrowing from software engineering was kind of the structure of code bases, right? Like separating the source code like into a little lib folder or a source folder or something along those lines. Everything having its own little script where you can all just define stuff, and then when you run stuff, it's in a different place. And this was pretty fun. I had a lot of fun, just, plain old fun. It's a good time, right? Like, you can spend some time like figuring out how you want to structure your code, and like it feels a bit of a puzzle. And then you can also very well procrastinate by refactoring old projects instead of actually making. After, I figured out my formats and what I like and my templates, I started feeling that there was a bit of resistance in there. And again, as I said, you can procrastinate with these mega hard. And I just noticed that I spent more time kind of like factoring or refactoring my code than, actually doing the research. And I started noticing some of the like more fundamental differences between like, a software engineering context and an empirical research context on the same style of code. I think the main difference is that when you're a software engineer, you are making a piece of software, right, that will be used by one or more people indefinitely, hopefully, right? And this is why maintainability is a big deal. And why your code has to be readable and usable by someone else, because eventually, you might leave a company or whatever. But in an empirical research setting, this is a bit different, right? Because most research analyses don't have to be run over and over again. We are not building a product or an application. We are building a pipeline that has to run exactly once at the end of the day, right? Of course, you will want to run it multiple times and experiment, blah, blah, blah. But essentially, in a research setting, you want a pipeline that runs once and then it's done, and then you know your results. And when I realized this, I also had this feeling that maybe this insane, decoupling and separation of concerns and all of these fun buzzwords from computer science and software engineering were an overkill for the research projects that I was running, right? Because at the end of the day, if I would have the stomach for it, I could just have one single Python file or R file with 1,500 lines that just does what I want it to do. And a lot of people do that, right? And they have great careers in academia, and you can just do that. And I had to realize that I was over-engineering it. As I was kind of simmering on all of this, because, this was a big deal for me, because I spent a lot of time figuring out how to do it better, and now I had to realize that what I have been doing was an overkill all along. So as I was figuring out what to do here, I ran into two essays, or one essay in the main essay, and then I read a second one from here. And the first one was the Grug Brain Developer. I'm going to link it in the description. It's a unique read. If you read it, you will understand what I mean. And the second one, it referred to locality of behavior as a principle to kind of govern your choices when you're designing software. The Grug Brain Developer, the main idea is that complexity is bad and too much abstraction, and because abstraction is great and everything, but too much abstraction just invites a bunch of complexity into your code that might not have a place there. And as a solution to kind of how to figure out how to balance the complexity and simplicity requirements in a code base, the principle of locality, and essentially locality of behavior, means that as you read a piece of code, you should understand what it does just by looking at the immediate context of it. So, for example, if you have a massive function and then, you just have a bunch of completely cryptic variable names that reference stuff in 5 files over, that's not locality of behavior, because as you read that, you have no idea what is happening. And as I was thinking about it, in a research setting, this is probably the most useful principle for you, because either it's going to be you in the future who is oh yeah, I remember, 5 years ago I wrote a paper that had an analysis similar to this, let me dig up the file, and then you're going to go to your GitHub, and then you're going to go open up analysis.py, and then you're going to go right there, and then that's the moment when you need to kind of be able to get up to speed on what is there very quickly. I kind of picked my hill to die on, so to say, in terms of how I want to structure my code. But what does that look like? I think currently, and this is, subject to change, everything is subject to change, I'm learning here. But my current approach, I think, will involve kind of defining a file for each step of my process, right? So if it's data processing and modeling and blah, 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 then it will just have a file each with all of the functions that I reference in there. So instead of kind of separating it to source code where I define all the functions and then a run file where I call everything, I will just kind of keep stuff together and define a function and then call it below as needed. And I think that doing it this way will enable, of course, locative behavior, because like I'm within the same file. But I also found that like my preferred way of navigating a code base is just like fuzzy searching. So I'm very okay with having like 1,000-line file, because I will just fuzzy find anything I need in there. So I don't really need like this insane structure. I just need a few files in which I can fuzzy find. So as long as I'm consistent with my naming, I should be all good. Another important piece of the GrugBrain developer was kind of to only start refactoring once the code has like firmed up a bit, right? And the idea here is that as you start building something or coding up an analysis or application or something, the code in the beginning is very malleable, right? Because there is just a lot of uncertainty, right? You just don't know a lot of stuff. And then as you kind of move on with the project and then do more and more, and then the code grows and evolves, it will kind of like firm up. And then the advice from the essay is that you should only start refactoring and like adding abstraction as the code is firmed up a bit, because you might not know like what good objects would be, or what deserves a function, what don't. And then I really like this idea. And this brings me back to notebooks. We started the video on hating on notebooks, and now I'm going to recommend you use them. Ironic, isn't it? I think that the way and how I found myself working naturally, essentially, is that like you just grab yourself a notebook and then you start doing stuff in it. Just experiment, right? Because notebooks are very good at like quick experimentation. Everything is right in there. You can write your thoughts there in Markdown and explain what you're trying to do, and then just like run with that. And then once the analysis kind of like firms up a bit, right? Afterwards, you can start like turning it into, like actual nice code. But in the beginning, notebooks are pretty good for this purpose, right? You can visualize with them. You can leave the thoughts in between. It's great, right? So I think that's kind of my full circle moment with notebooks, that I will just start out with a notebook and then do the thing. And then once I kind of have a better idea of how I want to structure this whole thing, I will just start factoring it over to a nice code base where the guiding principle is localization of behavior. Essentially, I think the main takeaway here is that complexity should only be introduced where it's actually necessary. And sometimes the simple solution is going to be the best. So with that, I wish you a great time in not refactoring and over-engineering your code base, hopefully. And thank you very much for watching, and I will see you next time.